Hi everyone, welcome back to Statistics and Data Analysis. So in today's video, I'm going to finish our introduction about probability. Okay, and then starting from the next week, we will use probability as our tools to study statistical inference. Okay, so the first thing I want to do is to um, strengthen your ideas about probability. To do that, I'm going to give you an application about controlling your inventory of your product. Okay? Here, I will only use the mathematical tools we introduced in the previous video. And that's going to help you wrap up all the ideas to really do some managerial decisions. That will be my plan for this video. And then in the following videos, I will talk about continuous random variables. So you know that for random variables, they may be discrete or may be continuous. Continuous random variables are extremely important for some reason. We will see. And today we will introduce the basic ideas and in particular talk about something called the normal distribution. So let's start. So this is an application, so there must be a story. Suppose that you are selling some products, let's call them apples. So these are apples or some kind of fruit or whatever. For these apples, you may purchase them from a supplier and the unit cost is $2. And then you may sell them at a retail market and the sales price is $10. Okay, this has been fixed and cannot be changed by you. Then your question is very simple. How many apples should you prepare at the beginning of each day? Okay, so we call this an inventory management problem because your decision to make is how many to prepare. How large should be your inventory level? Obviously, you shouldn't get too much, you shouldn't get too few, because if there are too much, then those leftovers basically are valueless or have very limited value. Okay, these things are apples, so after one day they are not fresh anymore, and then their value will decrease a lot. So you don't want a lot of leftovers. At the same time, you don't want to have too few because you may actually have a high demand, right? If you don't have that amount of apples, you will get some lost sales, which is not very good. So you are trying to find a balance between overstocking and understocking. So that's why you really need to get some ideas about your demand. Your demand naturally is random, right? Otherwise, you don't have any inventory problem. So let's assume, according to your expertise and historical sales data, you somehow predict that tomorrow's demand will be something we call capital X. Capital X is a random variable, okay? And in particular, it's a discrete random variable because we assume that you will sell either 0 or 1 or 2 blah 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 up to 8 apples. Okay, we assume these are all the possible values of your capital X, your random demand. So here we do not care about how do we make this prediction. That will be some topics in future lectures. But here we only want to take this distribution, this probability distribution as an example to do some interesting things on it. So the probability for you to sell nothing is 6%. The probability for one guy to show up and want to buy the apple is 0.15. Here I assume each person is willing to buy only one apple. Okay, so the probability for you to have 2 units of demand is 22%, and so on and so on. So the probability distribution can naturally be depicted like this. So you have several possible values for your daily demand or tomorrow's demand. And for each possible outcome, there is a probability. Okay? Sum of the probabilities goes to 1. So this is really a probability distribution. You list all the possible values, and for each value there is a probability for that to occur. Here, I would take this chance to introduce some terminologies to you. A distribution, okay, this is a distribution. A distribution may be positively skewed if there is a long tail at the right, okay? Just like this example. We probably can say that there is long tail at the right, okay? For large values, there are a lot that may happen, but they only have a small probability to occur. In this case, we say there is a long tail at right. Okay, so those graphs would be generally something like this. And then we say these are positively skewed. If on the other hand, your distribution looks like this, there is a tail at the left, then you have a negatively skewed distribution. Or if your distribution is just symmetric, there is no such a relatively longer tail, then your distribution is just symmetric. So these are just some common terms that I want you to know. Anyway, in this case, this is a positively skewed distribution. And then, given this distribution, we want to make the best inventory decision. What is the best? Is to maximize your expected profit. So let's see how to do this. If we are researchers, or if we are very experienced inventory managers, we know that there are some efficient ways to determine the optimal stocking level given any distribution demand distribution. Okay, if you take this course, operations and service management, then Professor Guo Professor Guo is going to tell you how to make the optimal inventory decision. What's the rules for selecting the optimal inventory level? Okay, but we are not there, so let's just use the most stupid and the stupidest way. How about we just try all the possible actions? We know demand may just be from 0, 1, 2 up to 8. So in total, we only have 9 possibilities. We only have 9 possible ways to prepare our inventories. Why don't we simply try each of them? If for each possible stocking level y, I calculate the expected profit f of y with that stocking level, then I will be able to find the best stocking level. That's going to be the one with the highest expected profit. So let's do this. Suppose I order nothing from my supplier, then tomorrow obviously I will earn nothing, right? No matter how many consumers show up, I can sell nothing. So my expected profit will just be 0. If I order 1 apple, then it's somewhat different. When I order 1 apple, okay, 1 apple, then I know I may either have a stock out or I may have leftover with probability 0.06. Okay, with probability 0.06, there may be no consumer at all, and then I will lose negative $2. Okay, why do I have this loss? Because I paid $2 to my supplier, but tomorrow I didn't earn anything. So in total, my loss is $2. However, as long as I am not so unlucky, as long as I have 1 customer, I can get $8 as my earning. That's the sales revenue minus the cost. Okay? And I know the probability for that to happen is 94%. How do I know that? So obviously there are two ways. First, I may sum up all the possible probabilities here. Okay? I know the probability for me to see at least one customer is the sum of the probabilities for me to see one or two or three or blah 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 or 8 customers. According to the probability law you learned 2 weeks ago, you know probability, and let me write it down. You know the probability for x to be at least 1 is the sum of probabilities for x to be a number that is greater than or equal to 1. Okay? And you have all those numbers, so it's simple. Obviously, there's another way, which is to use 1 to minus the probability for x to be 0. Okay? Because this event and that event, they are complements. So the sum of their probabilities must be 1. Anyway, you know, this is your probability. And then we may apply our knowledge about the so-called expected value about this. With probability 6%, I lose $2. But with probability 94%, I get $8. So my expected profit in this case would be $7.4. Okay? If I order 1 unit of apple, this is my expected earning, or I should say expected profit. Okay? Well, that's something we can do. As another example, suppose I order two units, then things becomes more interesting now. Okay, suppose I order 2 units. Then in this case, I need to differentiate 3 different situations. There may be no customer, there may be 1 customer, or there may be 2 or more customers. As long as there are 2 or more customers, I am going to sell everything I have. In that case, I will earn $16. Okay? And I know the probability is 79%. Again, that's something I can calculate by summing up all those probabilities. If I have 1 customer, I will sell only 1 apple. Okay? But I still need to pay $4 to my supplier because I already bought those apples. So in that case, I earn $6. Or if I am very, very unlucky, there is no customer at all, my loss is $4. So again, the expected profit in this case can be calculated by doing a weighted average of my 3 possible outcomes. I may lose $4, earn $6, or earn $16, and the weighted average is according to their probabilities. I find that I may earn $13.3 in expectation. So ordering 2 units is better than ordering 1 unit. If I keep doing that, I will be able to find f of y for all the possible values of y, and then I simply need to find which one is the largest. So let me skip that process. You probably want to do these kinds of verifications by yourself, but the idea is just as simple as in the previous slides. I have done here, here, and here. I can keep doing so, and immediately I can see the optimal stocking level is 4. Okay, here. When I order 4 units, I find the optimal balance between ordering too few and ordering too much. I don't want to order too few because I lose some money. I leave some money on the table. I don't want to order too much because then I take the risk of overstocking. So this is my best choice in this case. Okay, when the cost is $2 and the retail price is $10. To make our life more interesting, let's ask the following question. What if, after 1 month, the supplier raised the unit cost of my Apple to $4? Sorry, is 4. Okay. Previously is 2. Let's assume the supplier raised the cost to 4. Okay, how may I know whether the optimal stocking level is still 4 or not? We certainly want to know the answer, right? And the way to do that is again very simple. We simply need to recalculate everything with the new cost $4 to replace the old cost $2. We can still finish that. So to complete the whole analysis, let's assume the unit cost may be 1 or 2 or 3 or 4 units. Okay, so we have 4 different scenarios. For each scenario, we may be able to draw a curve like this. That's a curve connecting all those expected profits under different ordering policies. Okay, and then easily we can see if cost is $1, this is the optimal order quantity. If the costs are $2 or $3, then the optimal quantity is 4. Or at the end, if the cost is $4, then the optimal level is here. So numerically, we are able to solve all these problems and find the best inventory level to optimize our own expected profit. Okay, so that's something very useful. In general, for all kinds of product managers or manufacturing managers, they need to do these kinds of calculations so that they can prepare their production or prepare their ordering, their inventory levels in advance. Okay, that definitely needs to have some probability ideas in mind. That definitely needs to somewhat estimate the future demands. Okay, here I leave a question for you to think about. Does the optimal stocking level always decrease when the unit cost increase? Here, according to our 4 experiments, this is true. When the cost goes up, the optimal order quantity goes down. Okay, you probably want to think about whether this will keep being true or not. Yeah, there is an answer, but I don't want to tell you. Anyway, try to think about it by yourself. So I hope this example somehow gives you more ideas about probabilities and how it may be used in the business world. This is just one example, and we will see some more in the lecture. Thank you.